Okay. Okay, so if people can start sitting down and shutting up and stuff, that would be good. Uh-huh. I wasn't calling anybody in particular out.
I can't remember if I have to see him again, get the facial recognition.
Hey. What is the fees and sure? I just need to see what exactly it says.
The pink box.
I just wasn't sure what the wording was.
Yep.
And where's the star stickers? Yeah. Terry in a suit? That's terrifying.
That is kind of terrifying. And we have to apologize for lack of stickers. I don't know if we do.
I think we have stickers.
Nothing gets me more excited. I think it was in the airport.
Nothing gets you more excited than stickers?
Well, then warm with stickers. Warm with stickers. Yeah, that's the most exciting. So.
Okay. All right, if people could please sit down and stuff with... Okay. Cool. So, hello everybody, and welcome to Dprive. We're going to be talking about DNS privacy, and is my mic actually not on? That explains why no one's listening. Hello! Oh, is this working any? Wow, I'm going to have to eat this mic. Okay, so hello everyone, welcome to Dprive. We're going to be talking about DNS privacy and encryption and stuff like that. If that doesn't interest you, feel free to leave now or read your email or whatever. This is us. Somebody agreed to be a JavaScribe, but I can't remember whom. Who was that?
I was thinking it was Dan. I know Aziz offered to take minutes. Yep, there he is.
Aziz will be minuting. Who is the JavaScribe? Anyone? You get a nice sticker, we believe. If I have any stars, you can have a star. Star for the JavaScribe? Anyone? Anyone? Ted Hardy, you want to be JavaScribe, don't you?
Yeah. Yeah.
There we go, you can have a star.
Okay.
I don't know why.
It's not gold, but just for the record, Ted called if you got anywhere.
Okay, so we have us subscribe and we have us minutes. Thank you very much. Also, for some reason, if you're talking, you have to stand within the pink box, which is not pink, but it is over there on the floor. Yeah. That's also, I think, where the trapdoor is. So if you go over time, I have this button, and yes, you will fall down. Note well. Hopefully everybody by now has seen the note well and understands the note well. This has lots of important information on. I am not going to try and interpret it for you. This is the sort of stuff that you should speak to your lawyers and stuff about. This is it. Make sure you understand what it means, please. Nope. This is not legal advice. You should ask a lawyer if you should talk to a lawyer about this. Blue sheets, these are now circulating, I think.
Yes.
People, please fill in the blue sheets. This is our agenda. Hopefully everyone has already seen it. I believe this is what it was when we emailed it out. Those who are very detail-oriented will note we have actually added an extra 5 minutes, which we don't have. This ends up being 5 minutes over time, so we're going to have to either skip the interpretive dance or make something else shorter. Still? Is this mic on? Okay. You know what? We're actually at the end of these slides, so I guess it doesn't really matter. Anyone have any issues with the agenda? Agenda bashing? Were you expecting to be on here and aren't? Okay. In that case, a quick status update. The DNS privacy considerations document from Stefan. We called consensus on that a short while ago. Stefan just posted a new version about 3 hours ago, so it is no longer in waiting for document Shepherd write-up. We finished that. We clicked submit. It is now our AD's problem. He's had it now for almost 25 minutes, so hopefully he'll do something soon. We are hoping at the end of this meeting to have actually managed to decide on a way forward. At the moment, these are the 3 documents which we sort of have. Confidential DNS we haven't really discussed much, but it is one that's on the table. We're going to be having presentations on all 3 of these documents, and we're hoping at the end of this meeting to decide which one we want to focus on, or potentially we will focus on a selection of them with the expectation that probably one or more of them will not survive. So that means basically please pay attention to the presentations. Hopefully people have read the documents, and we're going to be doing a bunch of hums at the end to try and help us figure out what we're actually doing from here on. And that is the end of the administrivia. First up, we have Alison with the evaluation of privacy for the exchange. Let me find the slides. Please. There is a clicker that's forward and back. Oh, and you need a mic. I stole your mic.
All right. Hear me? Okay. So it's called a touch of eval for your afternoon. Nobody gets it, I guess. Not many Hitchcock fans here. Or actually, it's Orson Welles fans I was thinking of. But all right. So the draft, this draft was posted.
Is the mic? Can everybody hear? Is the mic actually on?
All right.
Here it's quiet.
I will try. Okay. All right. A touch of eval. Aziz Mohizen and I, we were both AM, have a draft that we would like to actually have asked to be adopted here, which is an approach for doing evaluation of privacy algorithms. It's partly just a way to convince people to use the terminology from the Privacy Considerations RFC rather than saying vaguely, it's private, because there's a bunch of different aspects to privacy. The draft includes those definitions, talks about that, and has a lot of content, but I've only got 10 minutes. So I wanted to mention what we consider a couple of issues to still to talk about. One is that we broke out the attackers, and we're emphasizing the passive pervasive monitor, which is the attacker from the pervasive monitoring is an attack RFC. So that's the attacker who's on every link at will, and you have to understand that, and the attacker gathers and correlates all your data. But we also understand that there are times when a type 1B attacker, an attacker that's monitoring a particular link, is relevant, so we're not being that hard over. And there's the attacker who's an observer who has power over an entity in the DNS system, that's type 2. And so we actually define them all in order to allow people to talk flexibly about what threat they're protecting against. And I thought a picture might be useful. And then I'm going to explain those things better on there. But we have stubs, we have recursives, we have authoritatives. Up in the corner, there's a mysterious thing called B, which is a privacy broker, which is not in the document yet, but we realize it probably needs to be, given things that we think about when we create privacy-enhancing solutions. And the attacker is conceived of as a monitor who has access to information on a particular link, like S to R, or R to A, or S to B to the broker. There is a, that's really all that I wanted to say there, but it helps you to understand the document. If you've seen that picture, we should probably have a picture in the document. I mentioned the attacker models and the system models. Those Fs there are forwarders. When you do an analysis of open recursives, there's a lot of malicious forwarders all over the place, and I don't know whether we need to think about them or not, but the system allows for thinking about them. We may not need it right now, but we should think about this as a bigger problem. And there's what we have is a template. You fill it out. You'll have seen that Stefan has filled out the template for Q&A minimization, and I really like what he did, and I think it helped to kind of sort of make a comparable item by having the template filled out. But the parameters are selected for the mechanism, and for example, we think that we should flag that you should have randomized cipher suites when you're doing something with TLS for DNS, because you're trying to go with unlinkability, and if you don't, you have some ability to do plain text attacks, that sort of thing. The privacy goals that are extensively named and given definitions to, the two that I think we should try to think about when we're talking is unlinkability, which means that the PII, the source, the person who's making the query, is hard to link to the query. You might see the query, but you can't figure out who sent the query. And then undetectability, which adds that you don't get to see the query anywhere in the system. All right? So I really think it would be useful if we didn't just say privacy or just say encryption, but we actually said the PII is being covered, other things of items of interest, IOIs, might still be exposed. Those are important things. And then going back to that picture again, the question is, when you have a mechanism, which monitor are you depriving of their ability to break your privacy when you have the mechanism? And I think that's a useful question. That's not really articulated in the document yet, but I think that's a good way to ask, where is it? So with encrypting SR, we're depriving monitors of SR, of lots of SRs even, because we're encrypting hopefully wherever. If we only encrypt to one recursive, but we send our unencrypted traffic to other recursives, we haven't actually deprived a pervasive monitor of their ability to see our privacy. So that's the kind of idea. And really just trying to help people use this document, especially if you want to adopt it rather than go through the whole document now. And as I said, I think we need to add this broker, this third party, because you can go to an anonymizer or a mixer or something like that. And we don't actually have a picture for when the monitor is up at B and can see you setting everything up and can actually have a lot of observation all over the system. Right? So that would be an interesting additional thing to talk about. I think it's relevant in the next talk, perhaps. As I said, so the monitor that's in systems, the monitor that is the observer in A, for example, the observer in the authoritative that Stefan talked about, is not all that well accounted for in the document. We would like to have people fill in to-dos and give us some help with these issues, and we'd also like to ask to adopt it as a useful tool for everybody. That's all.
Questions?
Any questions?
And while whoever's getting up to ask questions, can we get a quick show of how many people have read the document? Okay, good. Thank you. Question?
You should say your name too, Stefan.
Oh, the back one.
Hello, Stefan Bartsmeyer, AFNIC. First thing, for the people who did not read it, I recommend to read it, and also to try to practice, to fill the to-do. It's not only just to make more bytes in the document, but it's also a good way to be sure that you have really understand. The draft is an exercise which is not very common in the IETF. I don't remember a lot of exercise like this one, trying to evaluate in an objective way if something is good or not and what you can gain from this or this solution. So it's something that probably many people here are not used to. So it's a good exercise to read it and to apply it. Now a good example of a problem, I thought I understood the concept of a type 2 attacker, but now that you talk, I have adopted. You said that the difference between type 1 and type 2 is type 1 is passive and type 2 is active, but in the draft there is another definition. Type 2 is someone who controls one of the elements of the network. For instance, I work for a TLD registry, I control the authoritative name server. If I go evil, I don't know, am I type 2 or not? If I just collect the data that pours into the name servers?
So I think we have a little bit of a clash between active-passive measurement versus active-passive monitor, where it is the control that is the element, not the sort of insertion of data. So the fact that you have natural, appropriate access to all the data is, I think, what makes it active in this case. We could perhaps use a different term for it. The passive term was kind of given to us by the discussions from the RFC about passive monitoring, pervasive monitoring. But I'm not in love with passive and active as terms here.
Yes, but you use them.
Well, I have passive. I'm not sure what the right. So maybe we can brainstorm this. But you've got the right understanding. Although I saw Aziz shaking your head, you think he has the right original understanding, right? Do you want to come up and answer that question? We'll just take another moment. I'm not sure. My co-author is Aziz Mohsen.
I'm Aziz Mohsen, and I'm one of the authors in this document. And I think it takes only 5 minutes to read the definition, and the definition is really clear. So the first one is type 1A, and the second one is type 1B, and those are both, in a way, associated with the pervasive monitor, do not require any kind of compromise or active attack, in a way. The first one is pervasive monitor, and the second one is directly monitor. Still in the monitor world we are talking. And the type 2 is malicious adversary. The second type is malicious adversary. And the malicious adversary can be viewed as an active attacker who can, in a way, manipulate pieces of infrastructure or have enough capabilities of being on links that DNS traffic flows on.
Could I suggest that we meet after and we hash it out among the three of us and see if we can get it to be a stable set of terms? Anybody else? Question?
Marco Sanz, DENIC. I find this document very useful, and I just quickly skim through it, and it tries to formalize the nomenclature and the words we are using. What it's a bit striking is that the problem statement document does not use this terminology. And now I know that because it predates this document, but it's a bit of confusing because we have two different ways to describe the problem. And I know this is not a problem statement document, but it uses lots of terminology, unlinkability, undetectability, that could be used in the problem statement.
So I thought of this as that this is an eval document, and we don't need to formalize Stefan's statement. Stefan's statement provides us with kind of a tour of the problem and a description of the attack surface. I don't really see a reason why they have to match. You know, there's that expression, consistency is the hobgoblin of the mind. We don't have to have everything consistent for our purposes here.
As a draft author, I would like to remind everyone that timing is very difficult at the IETF. There is also another problem in the draft problem statement. It's a lack of dependency on the Hoffman draft on DNS terminology, because it seems that this draft will not be ready enough, soon enough. So sometimes you have to say, okay, it would be nice to wait, but if we do, well, nothing will ever be done. So in the case of Alison work on the evaluation of proposals, I believe that the good solution is to rely on a common basis, which is RFC 6973. That's its normative reference for the problem statement. And today, the draft on evaluation use a terminology which is different from the one of RFC 6973, and in my opinion, it should align on this RFC, especially to use more neutral terms. For instance, don't use attacker, because attacker is something which is some sort of moral judgment, while observer is more neutral and apply to a wide range of entities. So probably for things like unlinkability and things like that, I believe they are defined in RFC 6973. Am I correct?
Yeah, you are right.
Yeah. So there is a common dependency.
And we're cutting the mic line off to Andrew. We were served, yeah.
Andrew Sullivan. there isn't actually any reason that the terminology draft has to take like 11 billion more spins in order to get it out, right? Because we could always produce another one. It's not that hard to do. We just like publish another draft and run it through the process. So one answer to this is if it's really important that the terminology draft get out, we should just work on that and publish it.
Okay. So I think when we were looking at it, we figured Stefan's use of terms was clear to somebody sort of approaching the topic for the first time. And so having it easily readable might be more important than absolutely precise.
That's also fine with me. I don't feel religion about this. I was just, if people think that the problem here is that we're going to define them in more than one place, let's just do it.
Yeah.
Thank you. And next up we have Philip. Let me just find the slides. Would you like to use the ticker? I'll let you know when you've got like 5 minutes left or so.
Okay, I'm Philhan Baker with Komodo. I've got to be in the...
You gotta be in the pink box. It's not.
Oh, and while Philip's getting in the box, what we'd like to do, if there are questions from Jabba, the Jabba scribe can jump to the front of the line.
Okay, so private DNS. I started working on another project which was higher level, which was OmniBroker, and the idea there was a mechanism that you could get the DNS name, the OCSP token, the TLS certificate, everything you would want to connect to a website or a web service or whatever, all in one go. We spent quite a lot of time on that. It turns out that the DNS, just doing the DNS component of it, is just a different application of the same technology. So objectives for DNS, specifically privacy, we want to do confidentiality, but we also are aware that we want to do some degree of traffic analysis, resistance, while taking into account the fact that we're not going to get absolutely perfect traffic analysis unless we do rather more than people are going to be willing to do. Authenticity, we want to be able to eliminate response spoofing. So if people are going to go to private DNS, well, people are going to want to have the assurance that they're going to the actual website that they intended to go to as well, even if that website doesn't happen to have DNSSEC deployed. Another one that's critical for us is guarantee the user's choice of resolver. We have 300 odd people who work in Turkey. We have a very large number of Turkish users. We've got 3 million people working our web browser, using our web browser. So this is all, at the moment we have a DNS resolver that we're running. People are using that for important purposes. We want to have this new protocol be something that we can use to guarantee that people can get to the DNS resolver they chose and not the one the state wants them to have. And service, if we introduce a new piece of technology, it must not defeat the countermeasures that are currently in place for DDoS attack mitigation. And in my view, that means we've got to provide an answer to DNS, attacks against the resolver, resource exhaustion, and also preventing amplification attacks. And that gets back to authenticity. We're going to authenticate every request and every response. So constraints. Previously, when I was trying to get, when I started, it was a mechanism that we were trying to get the web browsers to do OCSP status validation. And I think that if you're looking in terms of security, checking the validity of the certificate of the website that you're trying to connect to probably ranks higher as a security concern than encrypting your DNS client resolver. At the very least, it probably ranks on the same level. So whether you agree with these constraints or not, these are the constraints I heard when I tried to sell the idea of OCSP resolution to the browser vendors. And these are the pushback that I expect that we will get if we're trying to get the browser vendors interested in doing private DNS. So these aren't my constraints that I would want to live in, but they're the ones that I heard very loud and clear from the Google team in particular. Eka?
Eric Rescorla, browser vendor. So, I mean, I think these are reasonable. I think there's a reasonable set of assumptions, namely that things have to be faster, and they must basically work. But I'm really wary during a comparison to OCSP, because the things that made people sad about OCSP were not exactly these. And in fact, if you talk to Google guys, they're like complaining that OCSP is useless, not that it not that it makes things, and it also makes things slower.
Well, yes. In terms of I don't want to get rat-holed into OCSP at this point, but when I suggested a protocol for doing the OCSP lookup, they said that these were the hard requirements that they would have, that anything that they do has to work absolutely anywhere. So if somebody's taking their browser and they want to use it in a coffee shop or a hotel, it's got to work without any interruption. And they are very keen that they do not want to see any increase in latency whatsoever. So if their DNS goes up from 1 round trip to 2 round trips, that's finito, end of conversation, is the pushback that I got. So if you can go to them and say, if you can get them to come here and say differently, that's fine. I'm just telling you the constraints as I receive them, okay? So I did manage to twist their arm and get them to agree that, okay, yes, if we're dealing with corner cases, a fallback solution that is going to impose some performance penalty will be acceptable so long as it's not more than a few %. So the architecture is divided into 2 parts. The first part, establishing a long-term connection to your to your private DNS server. So in this model, you're going to pick a provider of your DNS resolution service, and you're going to stick with it. So no more, I'm eating my coffee in Starbucks today, so I'm going to get my DNS service from Starbucks. I mean, that's just stupid. People should be able to choose the DNS service provider they want and stick with it and get that wherever they are. So the user specifies their resolution service, so it could be dns@example.com, and then we have a small protocol, it's JSON REST, it's pretty simple, uses TLS, and we use that to establish a long-term connection to the server, where long-term depends upon how much unlinkability you want at the resolver end. If you want a lot of unlinkability at the resolver end, you're probably going to want to drop the connection and re-establish it every time the IP address changes. If, on the other hand, your priority is to get through state-imposed censorship, then in that case you might want to have a longer-term binding, because if the state is blocking the access to the session establishment infrastructure, that's a denial of service attack port. So I'm using TLS and WebPKI to establish that connection. Okay, so that's going to take a little bit longer, but this isn't inside my transaction loop, so that's not a concern for me.
So this is getting to be a bit reminiscent of Tor egress routers, and the problem with long-term connection is people can start to correlate the things coming out from those, and there's quite a bit of research on that, well, engineering and research for Tor to improve that. And there's also some considerations about tolerating more performance hit in order to get more bulletproof privacy. So I just want to put that context around what you're saying, that there's an existing, well-worked context here from Tor.
Yeah, I mean, there are issues, and which way you want to go depends upon, if somebody can give me the exact privacy parameters they want and get everybody on the planet to agree that those are the only goals, we can generate issues, yes.
John Dickinson, Synodon. Did I hear you right on the previous slide?
Yeah.
When you said that the end user will have to choose their DNS provider and stick with it?
Pardon?
That the end user will have to choose their DNS provider and stick with it.
Well, presumably most people would want to. I mean, like I've chosen my DNS provider and stick.
Most end users don't know anything about DNS, and they should not have to know anything about DNS.
Well, so this depends upon how you expect the parameters to get if you're going to have a mechanism that means that you move into the coffee shop, and the coffee shop is now providing the DNS service, you ain't going to have much privacy. So if you don't authenticate the server and you're telling the server where you're going, you're not going to have privacy. So there is a basic requirement here, but you have that at least as an option. Now, the way that we will be packaging this, in fact, the way we package it now is, since we provide the antivirus to these customers, they're getting their DNS service bundled with the antivirus. So, okay, so the resolution, so that's the session, the hard part of the architecture. The actual transaction loop is a simple resolution protocol, basically UDP DNS protocol with a very lightweight jacket around it. So saying, okay, here's my request packet, more than one response packet. Now the reason for that is, if you look at most DNS transactions, today most people do an A record and a quad A record. And if you say, well, it'd be nice if we could do SRV or Dane or whatever as well, and the pushback that comes then is, well, I only want to do one round trip, and if I make multiple DNS queries, then there's protocol stacks there that will introduce more than one round trip because they will only allow me to have a certain number of DNS requests outstanding at once. So the idea here is, well, I can fit all my DNS requests into one packet. The reason that I can't do that today is because there's a bug in the DNS protocol. Although you can have multiple queries in a DNS message, you can only have one result. And that makes it practically impossible to use the multiple queries feature. So here the idea is, as part of the framing, we just work around that bug. So to ensure that there's no more additional load on the server, your request is still going to be one packet. But if the response happens to be a bit more than one packet, well, you'll get your first UDP packet and it'll have a header that says, hey, there's 2 packets here. Wait for the second one. So it does introduce a little bit more state and complexity into the protocol, but I think it's well worth it because now we can assume that we're going to get the Dane, the DNSSEC, and the full answer chain back, and not worry about it fitting into 500 bytes or an Ethernet MTA or whatever. Eka?
Yeah, so I just wanted to circle back to your comment earlier about coffee shops and people. Sorry? Eric Rescorla. So I wanted to circle back to your comment earlier about coffee shops and having to configure your DNS provider. I certainly agree with you that as a matter of technical fact, if you're simply susceptible to taking any random recursive resolver that's advertised to you in DHCP, then you're not going to have any security against active attackers. So I guess my question for you, and maybe for the chairs of the working group, is: has there been some decision that what the threat model is here in terms of active versus passive attackers? That seems like a primary question when we need to answer in order to assess the suitability of any of these mechanisms.
Well, ask the question.
Well, sort of it depends on where an active attacker is, right? An active attacker in the coffee shop is different to an active attacker in the network.
Sure. I'm assuming someone who controls your DHCP service, let's say that, your wireless environment.
The short answer is no, I don't think we have fully decided which. I mean, I think that what had been discussed earlier was people who care about their privacy in particular are likely to choose one and stick with one. Whether everybody will do that, that's probably expecting a little much from most people. So I don't think that that's set in stone.
Okay.
Maybe it should be.
Yeah. I was just making it hard for me to assess what I'm hearing. So. Yep.
Yeah, I mean, from my point of view, if I've given you the option of choosing one and sticking with it, it is very easy to add in the model for let's do the promiscuous trust thing. Yeah, that's simple.
I mean, I, for example, and many people, I think, have configured like 8888 in their laptop, and they use that, but they're somewhat more technical. They ignore what comes from DHCP. We're sort of expecting the same thing as what we thought, but that hasn't been formally discussed.
Okay, thank you.
Okay, so the main resolution protocol to meet that really tight performance requirement is UDP, and I can show you that I can show the browser folk that I will give them absolutely exactly as good a performance as the current DNS does. There's no performance penalty at all. In fact, it's slightly better here because you can make do with one request rather than having to wait for two. For that corner case piece, the 5%, then in that case I've got the option of a TLS fallback, which when you do the session connection, what you do is you get a series of protocols back, and it says these are the hosts that you connect to, and these are the protocols each host supports. So you get back a series of TLS ports as well, and they just give you fallback, so you know that you're always getting connectivity. So if we can just finish, and then we'll do the question. So application, so anonymous use, well in that case, you're not going to authenticate yourself to the DNS resolver. It's going to be a public resolver that just anybody can use. There's a quasi-anonymous case, which is for folk like us who are bundling this with our antivirus. At the moment, we provide our antivirus product for free, and the sell on that is we will fix your printer not working from the Wi-Fi via GeekBuddy. So at the moment we're offering free antivirus, but it's possible that there are people who would offer this with paid antivirus. So in that case you have to have some mechanism for establishing an account. Enterprise customers, again, you're probably doing split horizon DNS. Enterprises are probably the first place that will be using this, and certainly they would have to be the ones probably to get it into the OS X and Windows and so on. So there you definitely need to have authentication of the user. Complexity strategy, the resolution part of it, the UDP part, that is really, really simple. That is 2 pages in the draft, of which 1 page basically is the example. Yeah, we're not talking about a lot of complexity there. All the complexity goes into the service establishment mechanism, and that is in part because we designed this as a reusable bit, with the idea that you're probably not going to want to just connect up to one web service. The idea will be that when you're connecting a new device, this will be a way that you connect up to all the security services that your enterprise is providing. You authenticate once, and they're all configured at the same time. So I won't go through those. And there's an open question here is, I showed you the very simplest version because people will say, well, I want this as simple as possible. So this version that's out there in draft form at the moment is you initially negotiate a Kerberos ticket and a shared secret. People have been saying, well, wouldn't it be better if you negotiated a public key and did a key exchange each time the IP address changes? Well, yes, that would be a better way of doing it. The only reason it wasn't in there beforehand was that CFRG was describing ECC algorithm suites, and I wanted to wait until that had settled down. I knew which one to hop on before I spec'd that out, but that's very easy to add. So, questions?
Andrew Sullivan. So I got up here actually to ask a question very similar to what Ecker was asking, and it was really for the chairs, because it seems to me that what we were supposed to be doing in this meeting is to decide among these things, and we're going to need to answer the question that Ecker asked first, because this obviously assumes a certain model. But that's not what I'm going to ask you now, because you already answered that. Instead, while I was up here, I noticed that you had this Architecture 2 slide, and it seemed to me that Architecture 2 effectively says, well, I've got this other protocol, and I'm going to send DNS packets inside of it. And it seems to me that if we're going to invent a completely new protocol here in order to do all of this, we ought to just do DNS 2 and be done with it, because we've got so many other problems with DNS anyway that once we open the door, we're going to do it. Now, the problem is that this working group has chartered not to do that, because that would lead us until heat death of the universe, and so we're not going to do it. And so what I want to know is why this isn't just like DNS2.
Okay, so actually the way that it is architected, when I do that session in that establishment bit, at that point the resolver could come back and say, I also support DNS2. That could be one of the web services that it advertises. And in fact, I have a draft out on the Omnibrooker, which describes something that is a meta protocol above DNS and all that stuff. So there is a slot in there where you can do the so it does have a slot in there for a transition out of the DNS world. However, that is not a slot that is currently being advertised or filled because of the heat death of the universe problem. So the idea here is, if we're going to change the DNS client resolver protocol, let us at least establish for ourselves an escape hatch from the current DNS world. We don't have to take it, but let's at least make sure that we have that escape hatch there in case we decide we want it in the future.
And we're cutting off mic lines if you can keep them short.
John from Synodon again. So you went on to say that you're wrapping this service inside your antivirus software, and you're wrapping your antivirus software inside your enterprise product that you're giving to your customers. On that basis, do you actually need standardization? Because you're just writing a program that runs inside another program that runs inside another program.
No. To be clear here, today we provide this product as a service over proprietary protocols. Okay? We would like to be able to provide it over a standards-based protocol, because then it is something that we can one day hope comes supported in the box, out of the box configuration, without having to have plugins installed, without us having to support this back-end engineering thing. I mean, like, engineers cost me money. I would like to use my engineers doing stuff that's interesting, not supporting 20 different platforms and different filters and plugins and so on. So we want to do this in a standards-based way. We're currently doing something very similar in a non-standards-based way, and that's given us experience that I think means that we can talk about it with a bit of authority.
Okay. Paul Hoffman, I'll just be really brief to answer both Ecker and Andrew. The charter says the primary focus of this working group is to develop a mechanism that provides confidentiality between DNS clients and iterative resolvers. Thank you.
Okay, thank you very much. And next up we have Paul. Oh, Mike, sorry.
Not only did he not take the mic, he didn't take, it's not a pink box, that's white. Sorry. Yeah. So with no slides, so you can take that off. I had proposed at the last IETF I had proposed 3 different proposals for this, and I am now proposing 0 of those. And I wanted to give a quick update on that. So I had proposed 3 different ways of doing DNS over TLS, and in discussions after that, some people liked one, some people liked another. Unfortunately, I found 2 different people who have actually implemented 2 of the ones that I am abandoning. But in the discussions, what came up was, in fact, a single way of doing it was probably not going to actually solve what we want, which was getting around broken middle boxes and such like that. So I am now co-author on, am I up next also? On this draft?
Allison's presenting.
Okay, Allison's. No, well, I'm presenting. Yes, I'm presenting. So, okay.
Well
So I ended up merging one of the ideas into this draft. So for those of you who had read my 3 previous drafts, they're just going away. They'll just expire like many, many drafts do. The idea being that, in fact, a dual system, as we will describe here, will be part of it. So for those people who are saying, oh, am I still wanting that? No, not at all. Those are not in contention for this. So, okay?
Great. And now we'll have Paul Hoffman. Do you want the clicky thing, or do you want?
No, I will have you, because I'm going to try to keep within. I've got 20 minutes, right?
Yes.
Total. So I'm going to try to keep within 15, so we have time for questions at the end. So I'm now going to present on the draft that was already here earlier, draft Dprive Start TLS for DNS. And I'm sorry. Next. So what I'm going to do today is give a quick overview because it has actually changed since the last IETF. And then we'll talk a little bit about some of the ways in which we believe that it actually meets the charter of the working group and a few open issues and such like that. So what we're doing now is, it again is TLS over TCP, DNS running in it. So the DNS protocol itself is completely unchanged. TLS is unchanged, but we are running, the privacy comes from all the properties of TLS. So the protocol is this. You first try to do a port-based connection. That is with a new port. Client tries the new port to the server. If it's there, great. We're done. TLS starts up. You run TCP, DNS over that, completely done. If that doesn't work, so for example, if the port's been blocked or the server just isn't running it, you do upgrade-based, which is what was in the 00 draft of the document, which is you send a real or a dummy request, most likely a dummy request because you're still in the clear, on port 53 with a new EDNS 0 flag, which says, hey, I would like to upgrade to TLS with you. So if the server comes back and says, yes, I know how to do TLS, then you start TLS. Once TLS is started up, again, at that point, you're just doing normal DNS, TCP DNS, and if not, that means the server actually doesn't know how to do this. So one thing that's important in the protocol is we don't specify, but it can either be authenticated or opportunistic TLS. I'll talk about that in another slide. But that's it. That's the protocol. So try to do TLS initially on a new port. So no changes at all to DNS at all. If that doesn't work, do this with a small change where we're using the established EDNS 0 to say, I want to do an upgrade. Server says, yeah, do an upgrade. You try to do an upgrade. Of course, TLS might fail at that point, but then you're still just doing regular DNS. Next. So we had a lot of design decisions to have to make in this. One of the biggest ones is that we want this to be pretty much a drop-in for what's going on now. We don't want people to have to think in terms of how is the DNS changing, how is TLS changing, and such like that. So the current DNS infrastructure can pretty much remain the same. The changes are the client needs to know how to do this, of course. I mean, that's always going to have to change. And whatever server you're talking to may or may not know how to do this. If the server, the recursive server you're talking to doesn't know how to do this, not a problem. You just don't get any privacy, of course. So what we've sort of one of our bases is that some middle boxes do block unassigned TCP ports, but lots of them don't. If you're one that's if you are behind a middle box at that moment that doesn't block it, then you're going to get TLS, exactly like you would going, doing HTTPS instead of HTTP. Some middle boxes actually still block TCP 53. So in that case, you're better off trying to do TLS first. So you try port-based first, but that's actually not mandated in here because, again, we want the client to have some knowledge. If a client has a knowledge going, I've tried with this guy before and he actually doesn't know the new port, but he does know upgrade, just do upgrade first. That's something that a client can decide because really, we're not trying to say follow our protocol. We're trying to say get privacy. So the primary target of this working group was stub to resolver. That's what it says in the charter. However, the charter also allows for resolver to authoritative. So in the case of this stub to resolver, it's very unlikely you're going to connect to resolver, ask one query, and go away. Therefore, a long-lived TCP session, the extra startup, round-trip startup, will be extremely short. And in fact, Phil was bringing up the case of web browsers. You may have actually already spent that just when you got in because your DHCP server might have said, here you are, or whatever, and the first thing you do might not be a web page. It could be a mail access. It could be your operating system asking, how can I spy on this person in this other creative way at this address? So all of that, the TCP startup will happen just once, and it might happen before anything that is sort of time urgent. So we are not proposing any new cryptography, no new transports, just do this the way the IETF has already said to do private transport. Next. So the document, this is a place where the document is a little bit weak right now on purpose, because we're waiting to see if the working group chooses this as the proposal. Our proposal works both with authenticated, if you're authenticating the server, or if you're just doing opportunistic. Right now, today, almost every operating system, when it says how to do DNS resolution, will either say get it out of DHCP or will let you specify. And this doesn't change that. Do you want to? Okay. So if you're going to do authenticated TLS, you can absolutely do that. The cert that comes back from the server will have its IP address in it, and if that matches the IP address you just went to, great. If it doesn't, then you now sort of break on that. But opportunistically doing this so that you're getting privacy from anyone else is done just the same way as any opportunistic TLS is done, which is the client says to the server, who are you? The server says something that the client doesn't understand. The client goes, okay, no problem, and goes on.
Great. 3 observations, hopefully quick. Oh, Eric Rescorla. The first is, obviously, if you get the IP address of the resolver through the DHCP, that's not going to help very much. I'm
sorry.
Obviously, if you get the IP address of the resolver through DHCP, then validating the certificate, even if there was one for the IP address, doesn't help you very much because the same network attacker could simply lie about the IP address.
Correct. We assume that the network attacker would be on path for DHCP as well.
Quite so, yes.
Yeah.
Second observation would be that if you are, while it is another alternative rather than doing assuming the IP addresses in the cert would be to slightly enhance the interface by which you tell the browser about, or the resolver about the resolver is going to, and give it a domain name as well. And then you can use ordinary web PKI certificates, which has some value, although it requires a slightly wider channel.
Well, it also requires changes to all of your code, because at that point, if you're supposed to be matching on DNS names, you're actually going to do a lookup, which you can't do.
You have to supply both an IP address and a name, not just a name. Yes.
Yeah. Right.
Or
some random identifier. It could be just an identifier in there if you want to do that.
Quite so, yes.
Seems like, and that would be better in the case where you might latch onto one of many things at different IP addresses, sure, but you want them all to have a certificate issued by a public CA or your corporate CA or whatever.
Right. The third thing I would indicate is that if you're going to operate in a non-opportunistic fashion, namely that you should not fall back, then there needs to be some way to indicate that as well, and whatever that channel is an opportunistic channel by which to indicate the server's expected key material.
We're not dealing with that for 2 reasons. One is because PerPass decided not to deal with it. By the way, the front mic now works in case people don't all want to run to the back, but that's okay. But the other reason we're not dealing with that is it seems unlikely that you're going to be in a scenario where someone starts up a computer and wants to do something and has no access to DNS at all.
Right. So I guess speaking solely for myself, I don't see a lot of value in having strong authentication for the DNS server if you're willing to fall back to unencrypted DNS, because you can always be forced back onto it. And speaking as a browser manufacturer, I see zero possibility that we would ever surface that indicator to the user between those 2 scenarios.
Correct. And that's sort of the reason. I mean, if that's wrong and the browser vendor or the operating system vendor wants to say to somebody, you're now not, or whatever, that's fine. Right. We don't prevent it, but we aren't going down that path because that seems unlikely.
Right. I guess all I'm saying is I think we would be willing under some circumstances to have a setting that said, I insist you use authenticated DNS and don't do it without it.
Yes.
I do not think we'd be willing to fall back and then show the user some indicia.
Correct. That seems likely as well. And again, we consider that out of scope for this, but not either prohibited or encouraged. Yeah. So I've got another couple slides, but if it's on this one, go ahead. Okay. Well, but there's people behind you who may not agree. Okay. Please. Go ahead.
Oh, I'm the slides.
Okay. So 2 more slides. One is the changes since the last time. This is really quick. Again, the main difference from the presentation of Hawaii is it's now a 2-step process. Try port-based first because we think that that's very likely to work, and it's also a little bit faster. You don't have to send a dummy query, but if that doesn't work, whatever. We talked more about the motivations throughout the document. Obviously, more would need to be said if this is chosen as the working group document. And in fact, we have to make sure that the motivations of the document matches what's in the working group. We talked about a few more open issues, and they added me as a co-author, and they wanted me to put it on a slide, but I thought that was obvious. Last slide, we do have an implementation out there. There was an implementation discussion in Hawaii. The implementation is unchanged. There is lots of implementation experience with DNS over long-lived TCP, and that, we want to be clear, since we're running over TCP, there is no expectation here between the stub and the recursive that you're going to be opening and closing TCP connections. No reason to do that. If there is a reason to do that, if it breaks, that's fine, that's normal TCP, but we are not proposing to open and close TCP. We're expecting long-lived. And there's plenty of experience that says that that's okay, and of course then you're amortize the round trips. And if you want to do TCP fast open or TLS resumption, that can be there. You can, it's pushed onto the client. That way we get all this. So with that, Alice, why don't you come up here, since you said you were going to run the questions. I'm going to sit down.
There are people who might start screaming about having like zillions of TCP connections because we would never close the TCP connections. We're talking about long-lived. You get enough of a value by having seconds of TCP connection instead of just a few packets. So this is a tuning matter, and the resumption and the fast open give you a lot of help as well. They put a lot on the client. So I don't want people who operate recursives to think we're saying that we want to flood them with millions of TCP connections all at once.
Well, but you said you.
Okay, I can, yeah. Well,
And we have
Dwayne,
about-
okay, Dwayne could answer. Okay, I can answer questions.
We have about 8 minutes for
Okay,
questions, just a
yeah.
quick note.
Thank you, Paul. Leave me with a.
So, Peter Kortdinig, first of all, I think since this is to inform the decision that is on the agenda later this afternoon, the part of the, excuse me, the part with the initial synchronization and choosing the port is probably up for further discussion should it be adopted. That is not a conditio sine qua non, as we say, right?
We left it to implementation. Are you saying that you would say no additional port, or are you saying?
No, I was suggesting that is a discussion that would be postponed until after
Okay,
it has been.
I think that's fair. Yes.
Okay.
All right. Yep. Absolutely.
Second thing, and you partly answered that here. What is the assumption of the end system that is actually using the recursive resolver? Today we have different models. We have daemons on the end client that kind of multiplex and demultiplex all the DNS queries that come from the applications, but on the same side we have applications using a otherwise stateless resolver library independent of such. What I'm trying to address here is the number of TCP queries is something that might be a bit bigger than I've heard envisioned here, because you have multiple different applications competing and opening up, not closing down, but opening up a large number of TCP connections that then otherwise idle around.
Well, there's a DNS op document, RFC 5966 bis, which gives some guidelines about when when a client or is dealing with TCP, and it says reuse the existing TCP connection, and we know how to do these things in TCP. These are kind of well understood transport problems, not that we just need pointers to rather than solutions for DNS, I think.
Well, I probably didn't express that well enough. That it's the question of the number of endpoints, of independent endpoints on a particular system that you have.
I know, right, but John, I think our document, or Ray, I think the document now says use one TCP connection from the end system for all the DNS traffic. If there's one there, use it. Yeah, and I'm not sure I'm understanding the question.
I'm saying I have 15 different applications, and I appreciate the IETF document saying that they should all use the same TCP connection, but probably not.
Are you saying 15 different client applications, each running their own DNS resolver inside
That's
them.
why I asked, what is the model? Is the model that on the end system there is a unified resolver that multiplexes all these?
Well, yeah, you're talking about applications that are basically doing validation and terminating the DNS in the application rather than in the OS.
I think the answer is you don't have a model that could be a model, but it's not part of it.
Okay. And I forgot what my third question was. Anyway.
Okay, that was intentional. We got you distracted.
Paul Wouters. So this whole idea about either doing encrypted DNS to somebody you don't know or doing encrypted DNS to someone you do know is pretty fundamental. I'm not sure what this draft actually solves, because look at us right now. Most of us are on the IETF network. You just got an encrypted connection that no one else next to you can see. So your DNS packets are already safe from your neighbors in the same room. They're not safe from the resolver that IETF runs here because we've trusted to use them. Unless you decided after you got online with your laptop on the network that you used your own resolver somewhere else, and then you probably have some VPN technology to reach it because that's a pre-configured agreement. So I'm not entirely sure what this drafts at, and on top of that, this whole discovery mechanism I think will run afoul in the typical captive portal negotiations that you also need to go through. So I'm a little confused if this draft will actually solve anything.
So, I mean, I think we're imagining that, I don't think I have to answer that because it's a comment, but just the one thing I would say is that I think that there are numerous consumers of DNS who could choose to trust a resolver that offered this service, and they would have less exposure to the Snowden type people gathering their information and understanding their entire set of
So they would be
transactions.
on the local network?
Wherever they are.
So we're cutting the line at the end of the current one.
John has an answer to that too.
Mike.
Apologies, John Heidemann, USC. So specifically, there's a number of people who choose to use public DNS where they have a DNS termination that they trust, but they don't have a VPN at that site, and they would derive benefit from this.
And I think this is privacy for everybody, not privacy for people who have a deep understanding of the entire system. It's a form of privacy with a limited scope. Okay. Did the mic line grow anyway, despite cutting it off?
Nope, that was everyone that was there.
Right.
But we're going to have to keep the questions really short if we
Yep.
can.
So Wes Hardiker, and I'll try to keep it short. And first off, good job, Paul, for presenting something and then dodging the bullet and giving the mic to somebody else. That was keen.
I should give the mic to someone else.
I have a hard time seeing how any of this is going to solve the bootstrapping issue with authentication. I mean, I get the opportunistic encryption goal, but I fail to see how we are ever going to get to the point of maybe with a DHCP option, we can at least narrow it down to you have to take over DHCP, and we can reduce the problem space down to a single one. But how are you ever going to trust the certificate on the other side? I mean, you can't do it based on an IP address because most of them are 10001, so that's easy to steal from another source. You can't there's no way to anchor that TLS connection with an authentication scheme that I see working, and the nice gentleman behind me, I think still there, yes, has the exact same problem, and that bootstrapping of authentication is going to be nigh impossible. So I would even argue that we might want to go to DHCP at some point and add another insert that goes along with the resolver.
Seems like a decent idea, DHCP.
Phil Humbaker. Yeah, I got a couple of comments. One of them is on the UDP TCP thing. The overhead of TCP is also that it makes anycast work really badly. We have a constellation that's serving our DNS, and so I don't want to have any state on those servers at all, because the way the thing is architected, there is no guarantee that two packets that come in from the same source will hit the same host. Changing that ups my costs as an operator immensely, and there's just no way that you can address that with any stateful protocol, which TCP is. The other thing is that I think we've got to think about how we expect this to be originally, how this is going to get into deployment. And there is the Linux package route for the 0.1% of the population that actually pulls things up that way. And then there's the browser route. And I think that in the interim, what's going to happen is that this is private DNS. If it's going to get anywhere, it's going to get somewhere because browsers decide to implement it at the application layer on platforms that aren't supporting it underneath. And I think that there, well, Google has a very obvious thing to do in that when you turn on Chrome, it'll say, do you want to have private DNS? And you click yes and it says, oh, by the way, this will all go to Google, or you could choose these other providers. But that's how I think it'll be happening. And Mozilla and so on will be the same, and public DNS providers will have to make agreements with the browser providers to get into that initial list. So I don't think it is very difficult to get to the point of having that persistent connection to the DNS server. And think about how this thing is likely to deploy in practice. That's going to come for free for most of the people who are going to be using this early on. So I don't think that we need the opportunistic thing as a first, we don't necessarily need it on day one. It's a nice to have, and it certainly shouldn't be something that we architect for.
To expand on that, and I think that also was what Peter meant. If the browser vendor will implement, and I have 3 browsers running on my system, there will be 3 TCP connections. And the amount of TCP connection and the scaling of that, I think so far has not been researched far enough, because the DNS industry currently is running on a very kind of cheap and thin line. And you can do amazing things with DNS servers. And if you switch that all to TCP, there will be some cost, and somebody will have to take that cost, and that has to be taken into consideration. And one minor thing, answering or trying a TCP connection after you receive the UDP packet with a bit set, that sounds a bit like an attack vector to me. So the server has to, do TCP to the initial query with the TO bit will be TCP. Okay,
yeah.
Good. Then I misread that. Okay. And one thing on middle box, in your prior draft, you tried to iterate over the middle box, the possible middle box that we currently have. In this, I seem to miss that a bit. And the middle box's block TCP is one thing. Most of the middle boxes really inspect traffic and try to do intelligent decisions, which usually are not so intelligent. How do you get around that?
We have that problem everywhere that we're doing more encryption. Middle boxes are losing their DPI, and sometimes it's going to be something like SPUD that gives them some information so they can let it go. But that's not unique to here. We're responding to a call that causes that change for middle boxes.
And also, just to clarify that, the use of a different port potentially means that you're not going to have sort of the DNS ALGs looking at them and breaking things.
You still have the scaling problems and
yeah.
Right.
I found that the most draft in the working group is encryption technology over TCP. So I wonder, why not encryption technology over UDP, and is there any encryption technology over UDP?
Well, the next document has UDP technology over UDP. Our argument tends to be that if you actually want to amortize the setup of the encryption, you need something connection-ish. And there's some other good reasons to go with TLS because we understand it well. It's been well debugged. We're on the way to making these platforms, better all the time. So that's the argument. But see what you think.
Thank you.
And we did actually cut the mic line, so if it's really, really, really short.
Dan Wing, yes, I did write a DNS over DTLS specification before Dprive became a working group.
And we forgot to say.
Okay. And I think we have Glenn.
I think this is Glenn. Yep.
think you have 10 minutes, and I'll let you know in about 5 minutes.
Okay. Are you going to advance the slides for me?
Do you want to?
You want the click?
Sure.
Clicker or I click?
Great. I'm Glenn Wiley with VeriSign, and I'm actually channeling Wouter Wingards, and the slides are pure, unadulterated Wouter. One warning, if I were to like snap out of it and start snoring, it's because he went to sleep early. He's still in the Netherlands, so that's your warning. What we have here, confidential DNS, I think addresses all 4 of the main goals in the charter, and we'll see how that goes. You guys can call me on it if you don't think so, but I was satisfied with it. It uses both UDP and TCP, and it gives us algorithm agility, so we can add new algorithms as time passes and we find things don't work. We stay on port 53. And the hope is that the way we've done this, we'll dig into this in a second, the way we've done this, hopefully will survive middle boxes. I think this is deployable. We're offering opportunistic encryption, so folks can decide to use this or not. And we're not adding much latency here. It's really one more transaction per TTL. And what that looks like, you start off, we allow you to encrypt within the packet, the DNS packet. So you're seeing DNS headers, things that should look familiar to folks up front. The sections within the DNS packet are what's being encrypted. And it's encrypted with a key. There are a couple ways you could fetch the key. One of them would be we could have a DS record in the referring zone that has a flag set. So, you know, I think it's bit 7 in the flag. It says that you're not supposed to use this DS record for validating RR sets. We could use that to deliver the key. We're proposing a new RR type, which you could also put in the zone to fetch the key to do your encryption. Say, offer a public key. There's asymmetric crypto. It includes, one of the options would be to include a symmetric key within your query, which then would be used by the name server. A couple of ways to get the key. You can see here reverse DNS, and I'm fully aware of the limitations and mocking that might bring. But it is an option. Another option would be to create a new meaningful name that folks could put the records on. And so this R type that we've proposed, this would end up in the sections. What it amounts to is you make a query for root or dot, and within the sections, we've encrypted the actual question and answers. And so the new RR type gives you a way to flag what's actually in that encrypted RR, and all of the associated data ends up in there, including the keys and the answers, etc. So at the bottom here, you can see the summary. You query for .encrypt, which gets you the keys. You send your encrypted query. You get an encrypted answer. And if that doesn't work, if the server for some reason can't support it, let's say it decides that this is too hard and the box is heating up, it could decide to answer serve fail or some other way indicate that it's not supporting encrypted responses right now. See, I think that's it.
Has he deployed it as in a test environment?
Only in our dreams.
Okay.
Yeah.
Did it work well though? Yeah, did it?
Yeah, it did. Yeah, uh-huh.
You said that it would work UDP, TCP. I had brought up on the list why I thought it could work UDP once you want to melt down to have the cursor be triggered to melt down from the CPU. And I thought about it sort of indicated, yeah, maybe that's right, maybe we should do TCP only. So I don't think that it really is UDP, TCP in any same environment. That is, that no resolver would set up saying, I'll take these over UDP when an attacker could totally suck up my CPU without taking almost any of the hits. And yes, a CPU DOS attack, not a utility DOS attack, we're all susceptible to utility DOS attacks. So I think that it really is TCP at this point. I'm sorry?
Traffic. Bandwidth.
But what I'm talking about is an attack that would actually suck up all the CPU. It would have to do decryptions on something that someone would actually have to encrypt. They could throw crash at you, and you would actually have to do hidden elements to decrypt things that they didn't have to do. They could only decrypt. That they can't
That's interesting.
The other, I think the other significant issue with this though is then, even in that environment, you know, the current spec says we can either do asymmetric for all queries, and those again are larger. You're not doing a Diffie-Hellman to get a symmetric key, or we can get a symmetric key, but it's not forced. If it's not forced, then the resolver is going to be doing just an incredible amount more computation than somebody who's already done Diffie-Hellman the normal way, like in TLS or in whatever Phil's doing, to reduce that. So I'm not convinced on the we can do it over UDP, or even if it's on TCP, that any resolver would want to do this if it's going to be a lot more CPU work for the same amount of encryption. That is, it doesn't get you more encryption, it just takes a lot more CPU to do.
Okay, there's a lot. Yeah, you can...
I mean, those are design questions,
sure.
Really. You know.
I think they are, and I think those are things that are worth looking at. These are trade-offs we face with any of the solutions that we're considering. We're going to inject some new DDoS vector in some way or another, no matter how we change it. If we move away from the pure and glorious UDP model that we have today, we're going to create work for somebody somewhere on these platforms.
And so really the design question is how much work for getting the same amount of privacy.
Sure. Yep.
And we're going to cut the mic lines after Lorenzo.
Phil Baker again. Yeah, I mean, you don't want to do any ECC, you don't want to do any public key work until you've got authentication of the source IP address by some sort of round, so yes, you've got that in our stuff and the VeriSign stuff and whatever. We've also got the bit that before we will forward your packets, forward your request to an authoritative server or somewhere else, we will make sure that we have forced you to do a public key operation. So in the VeriSign stuff on my stuff, I'm not going to forward your request anywhere else until I've at least had a proof of work from you that you've done this public key operation. So we've got that denial of service attack. There is, however, a third issue, which is I have two sets of servers. One of the sets of servers which are actually doing the resolution, the servers that I'm using to doing the key negotiation are separate, and that's by design, so that if I go under denial of service attack, they may stop new people getting in and registering. They don't stop my transaction engine from going on, and that has to do very much with the true purpose, which ain't privacy in my case, it's preventing state-based censorship. So that is a consideration that I'd urge people to bear in mind when they're designing.
Sure.
And short questions, please.
Yeah, Raphael, so this is the first solution that really feels and smells like DNS. For me, I think the attack vector that you described is possible with the kind of, if you don't have the prior authentication, and I think with the others, possible other things that float around to do some lightweight kind of authentication also with the cookie stuff, I think this could be made to work to give something over UDP without kind of compromising the CPU, a total CPU attack.
Sure. I think so.
Lorenzo Colletti, feel free to hit me with a clue bet, but so for TCP, what's the plan to avoid head-of-the-line blocking? Is there pipelining, or is it just really one query at a time and wait till it comes back?
Yeah, so we didn't address anything beyond what, really what I've described is the essence of the document. So we haven't tried to solve some of the other existing problems. I think Wouter had a bullet on the initial slide about that. This really was focused on specifically the goals that we had for the working group. Although I think we originally put this together back in November of 13, and it just happened to coincide. So that hasn't been considered. It's not that it can't be.
But who's going to switch to TCP if they can only do one query at a time? In general, yes.
So to answer that, Lorenzo, this is Alison Mankin again. The 5966 explains that you do need to pipeline, and we know how to do that. We just don't happen to do that in our DNS implementations now. So this is not a turn it on tomorrow. Well, mailboxes that are encrypted will not actually deal with that. It just goes through. So I think that's it. I mean, but that 5966 BIS is covering that, and then the TLS document sort of points to that and also explains ways not to get in trouble when you're trying to use TLS in a performant way.
Thanks, Allison. Yeah, and to that point, there's a reason you couldn't pipeline there, and that's something you could certainly do.
Okay, great, thank you. I'm sorry we ran low on time. Okay, so I think sometime we're going to have another chat about sort of our base assumptions, things like finding out which set of servers you're talking to if you're going to get them via DHCP. I thought we'd had that discussion a while back, but I guess we'll sort of loop around again and do the whole do you want to choose who you talk to, etc. discussions. Anyway, we've now had a bar buff, and then an actual buff, and then a working group meeting, and then another working group meeting, and it seems that it might be a good time for us to actually sort of decide on a path forward, what we're actually going to be doing here to solve the set of problems. So, you know, figuring out what we're actually going to do, which one of these approaches is going to work for us, how to move forward from having the same set of meetings again and again. So there's two main ways we can do this. We can choose one of these sets of approaches and focus on that, or we can choose more than one of them and understand that we're likely to end up with one that the working group ends up working on. The other one will probably die on the vine, drop off on the side, etc. Whatever we decide now and on the list probably isn't going to be a final decision. If we decide to work on one approach and after a couple of weeks or months we discover that we've made a huge error, we can change our mind then, work on a different approach. After we spend some time, if we find we've got major issues, or if something comes along which is obviously better, we could consider working on that. But we might want to sort of decide how we want to go. So, if we do one draft, these are the current set of documents that people have. If we decide to do multiple, this is the sort of combination of all the different ones we could do. Woohoo! But if we were to decide to do multiple, chances are we'd only end up with one that actually ends up being implemented, sort of that wins out. The rest are likely to die. So, we will have some hums. Before we get into the hums, I think we need to know who actually has read all of the documents and feels that they can make some sort of useful decision on what we want to do. Okay.
A little less than half.
Yep, and obviously we'll have to, do this all on the mailing list, but getting a rough idea of how things are going. So, we will have 3 hums now. The first will be some people would like to choose an approach and use that. The second hum will be people would like to choose multiple approaches and go with that. And then the third hum is we don't know enough to make a decision yet. We need to go have a look at more of the documents. Where's the next place? Prague. We will likely do this all again. So, first set of hums, people who think that we should choose one approach. Oops, Peter.
Yeah, Peter Koch. I'm trying to ask a clarifying question, or actually get a clarifying response. What does it mean if you say we don't know enough and that's the third option? Then we send that back and adopt nothing as opposed to adopting 1, 2, or 3? What's the practical difference between the two letter options?
If people think that we don't have enough knowledge yet to make any sort of decision, then we won't decide anything now. People will go home and hopefully on the plane we'll read all the documents, and then we will at Prague or on the mailing list have a before Prague.
How is that different from choosing all 3 of the documents?
Well, Yeah, that's true. There could be another one that comes along. It is very similar to choosing all three. If we were to choose all three, I would then sort of be expecting that we're likely to put up call for adoptions for the three, sort of work on them. If people say that we just don't know anything, then we won't do anything. Does that make any sense? It is kind of messy, Hamzar.
No, it's fine. It's then more similar to adopting 0 of them.
Okay.
Thank you.
Okay, so the first hum will be, who thinks that we should adopt one of these documents? People who already hum now. Yes. The first hum will be, I would like to adopt a document, not I would like to adopt multiple. Does that clear? Okay. Second hum, I would like to adopt multiple documents. Oh dear. And option 3, we simply don't know enough, we can't make any decision at this point. Okay, so for the person who's taking the minutes, I was not able to tell any difference amongst any of those, and I guess I should have had a slide, which I guess is, darn. Okay, well, I guess what we will need to do now is spend some time on the mailing list, discussing things like our base set of assumptions on how you choose, one of these, whether you get it via DHCP, if you choose a provider and stick with that. And also, we're going to have to spend a bunch more time discussing the actual drafts. Unless anybody has a brilliant way out of this, and we don't have to look like idiots.
Sam Weiler. Is this thing on? Sam Weiler. Is it worth doing a binary up-down choice on each of the 3 to see if there are ones we really don't want?
Okay.
Yeah.
Yes. I guess.
That's,
but
that could help reduce the problem scope.
Both.
Well, we'll do both.
We'll do both. We'll do both. We'd like to get an idea, just so we're not in.
I'm actually more interested in solving this problem than having my particular solution adopted. Now, what I would like to see is if people who are going to deploy as either an operator or as a platform provider or as a web browser, if we could get those people in a room and get them to either in public or in private, so long as it's under IPR, I'm fine with that. If they will lay out all the requirements and that would get them to deploy and tell us what they are, I'm happy to work through, and I think that I can meet them. But, I would like to have, for me, the person, if you've got everybody in the room saying, yes, let's do A, and the 2 people that run the web browsers saying, well, actually, we won't do A, we'll only do B. That's kind of sad.
Yes, but I'm very uncomfortable with having some set of people be more important than others. And I realize that in the real world that is what it is, but having a select few set of people decide the way forward feels
No, that's
IETF-ish.
not quite what
Okay.
I'm saying. I'm suggesting that people who actually have a stake say what the stake is.
Feels similar. Okay. And short questions.
Okay, I'll tell you why I personally like option B. I'm creation Ritama for Microsoft. I'm looking at that in terms of implementation cost, maintenance cost, and deployment cost. And I like option B because it's the one that makes the least possible innovation. And having the least possible innovation for me does minimize a whole lot of risks.
Okay.
That's
So maybe actually to keep things short, shall we quickly try Sam's hum of who likes A, who likes B, who likes C? And then if it turns out that there are people who don't like it, or if one of them gets no interest, then we can just skip those? Yeah.
Yes.
Sure. Actually, I guess you're standing at the mic. Go ahead.
Yeah, although Much as I like being nominated as the decider, one thing that's worth mentioning is Firefox at least uses the operating system resolver. I think Chrome may still. I know Chrome looked up using their own resolver, but I think they may have backed that out. So it's not just the point being there's not just the browser vendors who matter here. Yes. Sorry, my point being. Sorry, no, I'm sorry. My point is, if your question is who would you need to get signed on in order to get software that worked? It's not just the browser vendors that matter.
Go ahead.
I just wanted to also voice support for option B. I'm actually doing that right now, the DNS over TLS over TCP, and sorry, I'm Daniel Kahn Gilmore. So Unbound actually has this implemented. It doesn't do the proper TLS, the proper TCP out of order responses so there's performance enhancements that can be given to improve it, but option B is like basically available to us right now if we wanted to do it. So I think we should do something that we can do.
Lars Lehmann from NetNode. I would just request that we take the cost of implementation out of the equation because that's a one-time operation. And we should have the focus should be on the user, just like Paul said.
Sorry, I didn't hear the last.
The focus should be on the user, like Paul said.
Okay. So, how do we do these hums?
Do the hums yes or no on each one, and we'll see.
Good with people?
No.
Hums yes, no on each one, just so we can get an idea of. Okay. So we will have 3 hums. Well, actually, technically 6. If yes for A. Hum no for A? Okay, for the scribe, the no hum for A was louder than the yes hum for A. Okay, hum no for B?
Yes for B. Yeah.
Hum... Hum yes for B. Hum no for B. Okay, the hum yes for B was louder than the hum no for B. Last one, hum yes for C. Hum no for C. Okay, I think that those were about equal, the yes and no for C. Okay, well, thank you. I don't really know what that told us, other than it was interesting and fun. You can't claim that you don't get to participate.
I mean, we'll probably send out something on the mailing list as well to be complete, yes or no on each one, so we can sort of count all that stuff as well. So, I know, don't get frustrated. So, we will have a path forward. It just may take us a little bit. So, all right. Thank you all. If you all hadn't signed the blue sheets, there's blue sheets up here for folks to sign.
Yep. You can't leave the room without signing the sheet. Oi.
Blue sheets.
Blue sheets.
How you doing?
I'm good. Well, I'm not so good.
And why not? You work too much? You luggage? I saw that. And actually, I saw it like 30 minutes because I couldn't sleep that night. And I almost, if you were down, I almost went downstairs looking for you. I was getting some beer out of the fridge in the room. I don't know if you're in this hotel or not. Yeah, I didn't think you were. I was going to go downstairs and look for you.
Wait, the what?
Yeah. Maybe you'd be at the key table.
This is the worst trip ever.
Oi.
The room looks small.
That is horrible. Yeah, I'm glad. Hey, did they get you?
Oh, no, not at all. No. Thank you for. No, not at all. That was needed to help us figure out.